Section 4.3 is titled Scientific Notation. An application of integer exponents occurs in scientific disciplines such as chemistry, biology, engineering, and astronomy when very large and small numbers occur frequently. Scientific notation is a convenient shorthand for expressing these type of numbers. So, let's go ahead and take a look at some examples. 10 to the third power. What is 10 to the third power? So you can put that in your calculator, of course. Do you remember the shortcuts for putting exponents in your calculator? If you are thinking y to the x or x to the y or that little caret symbol, you are correct. So 10 cubed, again, is the same thing as 10 times 10 times 10. Put that in your calculator. And what do you get? You should get 1,000. What is 10 squared? 10 squared is 100. What is 10 to the first power? It's simply 10, right? So notice the pattern here. 10 to the third. Notice that the exponent was 3. We have 3 zeros. 10 to the second. Notice that the exponent is 2. We have 2 zeros, and so forth. Now that you know what 10 to the 0 power is, it's not really much to think about or try to come up with because you understand that rule now. But I do want you to notice that there is a pattern. Notice if you divide each one of these numbers by 10, right, you'll notice that you'll get the number below it, right? If you divide 1,000 by 10, you'll get 100. If you divide 100 by 10, you'll get 10. And another proof that this is 1, you divide this 10 by 10, you'll get 1. Now, what is 10 to the negative 1? So if we divide 1 by 10, notice we will get 1 over 10. And 10 to the negative 1 is 1 over 10. 10 to the negative 2 is 1 over 10 squared, right? Because these are negative exponents, so we take that base to the denominator to change the sign of that exponent. And we know that this is 1 over 100. Now, I'm going to take a step further with the last two examples. Let's put these in decimal form so you would know what 1/10 means. As a decimal, 1/10 is 0.1. And what about 1 over 100? Well, that is 0.01. All right, let's take a look at this box on your right here. You have 6.8 times 10. Well, 6.8 times 10 will give you 68 if you put that in your calculator. All right, next we have 6.8 times 10 to the second power. So really that is 6.8 times 100, right? So in your calculator, what do you get when you put in 6.8 times 10 squared? You should get 680, right? And what I want you to notice is that, notice that with 10.8 times 10, really you are moving that decimal one place to the right because it's 10 to the first power. Likewise, the second example, to get to 680, you're moving that decimal here 2 places to the right because it's 10 to the second power, right? So notice in this case, because we had positive exponents, we moved to the right here. But here, 6.8 times 10 to the negative 1, if you put that in your calculator, you would get 0.68. So notice we would have to change directions there and move the decimal one place to the left, not to the right that time. Okay, so these are examples of scientific notation. Scientific notation. We just changed scientific notation into standard form. So what is scientific notation? Well, again, just as a reminder, scientific notation provides a compact way of writing large and small numbers. A number is written in scientific notation if it is written as the product of a number between 1, which can include 1, and 10, a number between 1 and 10, between 1 and 10. So this number right here has to be between 1 and 10. It can include 1, but it has to be less than 10. So this is what this symbol means. This means the T here can be greater than or equal to 1, greater than or equal to 1, but less than 10. All right, and normally you will have a decimal for T, and you have to have one number to the left of the decimal. And an integer power of 10. So you have a product. Product in math refers to multiplication, okay? Multiplication. So all they're saying is you have some number T that's between 1 and 10. It can be 10, but it can be 1, but less than 10, times, that's where the product comes from, times 10 to the n. N is an integer. Now, notice in the last section we talked about n, that you want your final answer to be a positive exponent. Well, scientific notation does not follow that rule for whatever reason. This n can be an integer, meaning it can be a negative or positive number. So that exponent is going to be negative or positive. So only in scientific notation do we keep that negative exponent. Normally we will continue, make it positive, and simplify. So let's write the following scenario in scientific notation. We have the distance from the Earth to the Sun is approximately 93 million miles. So here we go. This is not in scientific notation because, first of all, we need a number between 1 and 10, right? We established that. This is definitely not between 1 and 10. So we have to follow these rules up here. So what we're going to do is move the decimal. The decimal is considered to be right here right now. We're going to move it so that this decimal ends up being to the right of a number that's between 1 and 10. So we're going to move it 1, 2, 3, 4, 5, 6, 7 times. So it's going to be 9.3. Notice that 9.3 is a number between 1 and 10, correct? Then we're going to say times 10 to the 7th power, because we moved the decimal place 7 times. This is a very large number. Notice, a very large number. So when you have very large numbers like this, your exponent is going to be a positive number. And for example, the next scenario is a very small number, so I know that my exponent is going to be a negative exponent. So let's get to it. So we have this number 0.0000000077. All right, so to write that in scientific notation, we're going to move that decimal to the right 1, 2, 3, 4, 5, 6, 7, 8, 9 times, because 7.7 is a number between 1 and 10. But because it's such a small number, I know that it's really to the negative 9th power. Now notice above here, notice that 6.8 8 times 10 to the negative 1, that was a small number. And notice that it had a negative exponent as well. All right, so that's just a little tip for you to help you grasp the concept that in scientific notation, a negative sign on an exponent with a positive base is associated with a number less than 1, right? This is a number less than 1. So again, in scientific notation, a negative sign on the exponent with a positive base is associated with a number less than 1. However, a positive number, for example, let's look at the ones above. A positive number, a positive sign on the exponent with a positive base is associated with a number greater than 10. So these numbers are greater than 10 here, but notice we have positive exponents. This one, however, has a negative exponent, and notice that it's associated with a number less than 1. 0.68 is less than 1. All right, let's move on to the next page. Ultraviolet light emitted from a mercury arc has a wavelength of approximately 0.000025 centimeter. So, do you consider that to be a very large number or a very small number? So, it's definitely a very small number. It's not even 1 centimeter yet, right? So, we're going to write this in scientific notation. We're going to move that decimal 1, 2, 3, 4. We're going to move it 5 times, okay? So definitely 2.5 is between 1 and 10. And since we moved it 5 times, we're going to put -5 because that's a very small number. This number is less than 1. So I know I would have a negative exponent. Again, let's go to some different type of examples here. Write the following scientific notation. So this, can you see why this is not scientific notation? So again, if you don't get why, you still need to go back over the definition of scientific notation that's here. It has to be a number that is written as the product of a number between 1 and 10. And definitely here, 432 is not a number between 1 and 10. So we definitely want to change this because the decimal currently is here, and we need to move it 2 places to the left. Now, how does that affect this exponent though? Because we're moving to the left, right? So what's happening is, since we're moving it to the left, we have to compensate for that. We have to compensate for losing that those places, right? So really it's like 4.32 times 10 to the second times 10 to the -5th. So what this is right here is, this is really 432, right? 4.32 times 10 to the second is really, if you change that 2 places to the right, you get this, right? So in order to compensate for that, we have to put in that times 10 squared. And what is 10 squared times 10 to the -5? Well, we have the same base here. So because we have the same base, we can add the exponents, right? So this is really 4.32 times 10 to the -3. So this is in scientific notation because 4.32 is between 1 and 10, and it's a product of that number times 10 to some power. All right, next, let's move on to 3.4 times 10 to the third. So the instructions here reads, write the following in standard notation. So notice this is already in scientific notation, and we want to write it as a regular number, right? So since we have a positive exponent, I know that this number is supposed to be a number greater than 10. So we can move that decimal 3 places to the right. 1, 2, 3. And what we're going to do is just add some zeros here. So what we have is 3,400 or 3,400, right? Next, we have 2.1 times 10 to the negative 4. Again, we're going to move that decimal, right? I'm giving me some room in the front of this. So that's 2.1 here. And since it's a negative exponent, I'm going to move it to the left. 1, 2, 3, 4. So we have 0.000. If you wanted to add a 0 in the front of that decimal, that's perfectly fine, as long as you have 3 zeros to the right of that decimal point. All right, let's continue. We have the instruction, use scientific notation to simplify an expression. Scientific notation can be used as an alternate way of multiplying numbers. Obviously, you could simply just put all this information in the calculator, right? But this book or this textbook wanted to demonstrate that you can use scientific notation to multiply these numbers together. For example, you can multiply the 3.4 times the 2.1 together. So that'll be 3.4 times 2.1. You can write that together. And you can also group the 10 squared, right? And times the 10 cubed together if you wanted to. Now, again, obviously you can put this in the calculator, but 3.4 times 2.1, your calculator is 7.14. And then here, you know that you could simply do what to the exponents. You can add them because you have the same base of 10 and you're multiplying. And now, since you understand how to convert from scientific notation to standard notation, you can simply just move that decimal 1, 2, 3, 4, 5 places to the right. And what you get is 714,000. All right, next, let's go to the next example here. You have 9.3 divided by 3.1. So let me write that over. 9.3 divided by 3.1. We could work on that. And also, we can work on 10 squared divided by 10 to the negative 2. So what I did was just group them together. Not dissimilar to what we began with, but just showing you that we can work on this as a group and this as a group, right? So 9.3 divided by 3.1 is 3 in your calculator times, and this is dividing with the same base. So 10 to the second, and we emphasize that it's second minus a negative 2. So that's a mistake a lot of people make. They put 2 minus 2, but where's your subtraction symbol? All right, we identified that that's a negative 2, but you also have to put in that minus symbol, okay? So what we have is 3 times 10 to the 4 power, since we have a plus here, right? Negative times negative is positive. So this is 3 times 10 to the 4 power. If we write that in standard form, then you're going to move that 3.0. We're going to move that decimal 4 places to the right. 1, 2, 3, 4. And what do you have? It looks like we have 30,000. And last but not least, we have this C example. 0.0032 could be written as 3.2 times what? Well, if you change the decimal to 1, 2, 3, 3 places to your right, then would it be 10 to the third or would it be 10 to the negative 3? So notice that that's a very small number. This number is less than 1, correct? This number right here is less than 1. Therefore, we're going to have a negative 3 here. And then we have multiplied by 2.5 times what? This number right here is greater than 10. So when you move that decimal 1, 2, 3, 4 places to the left, then that will be 10 to the 4th power divided by, what is this number in scientific notation? Well, it looks like we're going to have to move that decimal 1, 2, 3, 4 places to the right. But would it be negative 4 or positive 4? Didn't write that right. Negative 4 or positive 4? So if you said negative 4, you are right. And now what we could do, we can group some things together. We can group the 3.2 together, right? We can group this 2.5 together and this 4.0 together. So you write 3.2 times 2.5 divided by 4.0. And then we can group 10 to the negative 3 times 10 to the 4 divided by 10 to the negative 4 together. Now you put all of this in your calculator, you'll just simply get 2, believe it or not, times, here you can add the exponents here, so negative 3, for example, plus 4, and again you could subtract a negative 4, right, from that negative 4 here. So we have 2 times 10, negative 3 plus 4 is 1, and 1 plus 4 is 5. So what you have is 2 times 10 to the 5th power. We can move that decimal 5 places to the right. 1, 2, 3, 4, 5. And what do you get here? You get a whopping 200,000. So this concludes the lesson on scientific notation. Again, if you have questions, please ask those questions in the problem solving form. If you're in the online class, if you're in the ground course, please simply ask your questions in class. Until the next time.